In the previous exercises and videos, we already played around with the data a little bit. In one of the last videos, we have looked at the co-occurrences of the two categorical variables. In the video, you saw that we can create a pivot table that looks at the co-occurrences of movies that are of genre drama and movies that are of genre comedy. And then in the follow-up exercises, you did a very similar thing with thriller and crime. The question really is whether this co-occurrence that we observe in the data actually is significant. Maybe it's just random. Sometimes things happen together randomly. To see whether there is some pattern, something that is actually going on, we need to conduct a proper statistical test. We are now looking at the relationship of the two categorical variables. Let's say we have our drama movie category and it says either the movie is drama, yes or no, this is a dummy variable, and the same thing for comedy, yes or no, comedy. So we look at the relationship of the two categorical variables. To assess the relationship of two categorical variables, we need a chi-square test. And then we see whether the co-occurrence of the events is random or it's more than random or it's less than random, if something is going on. So we're going to do the hypothesis testing and we're going to produce a p-value. Just to recap, and you read in your home assignment readings that p-value that we're looking for that helps us to reject the null hypothesis should be less than 5%. So what does it mean, just to remember? P-value, when it's less than 5%, then we can say something is going on. Something is going on and we are less than 5%. We have a less than 5% chance that we're wrong. Of course, in statistics, you cannot be absolutely sure. In general in life, you can never be absolutely sure in anything. That's why in statistics, people put a percentage number. We say something is going on, we reject the null hypothesis, we say H1. Alternative hypothesis, something is going on, but there is a chance that we're wrong. And what is the chance of that? That's the p-value that is telling us. And if the p-value is less than 5%, then we can accept this kind of chance of being wrong. So now let's try to get the hands-on experience and exercise a little bit and see whether genre drama and comedy co-occur randomly or is something going on. Okay, let's get to the actual statistical testing and we pick up where we left off. So we have our pivot table where we have comedy, yes and no, and drama, yes and no cross-tabulation. What we're going to test is whether there is the combination of comedy and drama is random or not. Is it more often and more common or is it less common than usual? To do that, we need to do a couple of calculations before we actually get our p-value. But that's actually not bad, that's good even, because while doing this calculation, you will actually get the feel of what does it mean, why is it random, what is it not, and how to interpret the results afterwards. To do that, these calculations, let's take some numbers out of our pivot table and copy them here, just so that we keep it more or less neat. It doesn't have to be perfect here because it's just an intermediate calculation stage, but let's call it what it is. Total here and total here. What we're going to do now, we're going to calculate how the split would be if it was random, and that will be our first step. Afterwards, we will compare whether truly random calculation that we will produce now to our actual data. So for this, we delete these bits here. And while doing these calculations, we will also do a recap on how to freeze cells and how to freeze only rows and how to freeze only columns. So what we need to calculate here is we need to multiply our row total by our column total and divide by the grand total. I would like to make it as efficient as possible, so I would like to be able to drag here and drag down here and have all the numbers calculated. But you see, now it seems that there is a problem, and the problem is there's nothing to divide by. That's not the only problem, however. So let's have a look. If I extend it here, look, my column ran away, it should be this one. My grand total ran away, it should be this one, but this one stayed the same. Good. And when I look down, everything ran away. It should be this column, it should be this, and it should be this. So instead of correcting everything like this and returning the formulas and the references back to their places, let's do an efficient formula. So we'll start over. And we're going to think hard to make it efficient. We click even. So for this cell, I need to apply my raw total. But what if I move the cell then here? This should be still column L, and remember it was right here, we need to move it back. So let's freeze the column. By this we will put a $sign before L, which is the name of the column. I need to multiply this value by the column total. And here, let's think about it. If I drag my cell here, it actually would be nice if it moves along from J to K. And here I will need K15. But if I move down, I still need it to be in this row 15. So we need to freeze the row. This will pull a $. Here. And then we divide by grand total. Grand total is identical for everything, so we need to freeze it properly by pressing F4. I freeze both rows and columns. If you press F4 a couple of times, it's gonna move and be only row, only column, nothing. So I need everything. Now, if I drag it sides and down, you will see that everything is correct. You can step on the formula and see. So now what we did, we actually calculated numbers that tell us, if the split and the co-occurrence or non-occurrence of drama and comedy together were random, this is how the numbers would look like. So what we would do is compare what should have been if these two variables were not related to each other. Each would happen independently to our data to see whether actually, in reality, comedy and drama are somehow related. There is a relationship, there is a dependent. When there is a comedy or a drama genre, they're not independent of each other. This is the point. So why did we use this formula? Does it actually make sense? Let's have a look. This is our total. So let's calculate the percentages out of this to make more sense out of it. Let's copy it again. So we already prepared all the numbers for our analysis. Now, before we get a p-value, we're trying to make sense out of it. And we want to say that we want to have the sum of this, just the same thing, and the sum of that. Except I am deleting this bit here, and this is not really relevant for us right now. What I will do, and I will say, okay, what is the share of no drama and no comedy out of total no comedy? And remember, I need to freeze the L. Because I do not want to move it from L, but when I drag it down, it needs to move. And if I extend it here, what I am calculating is the share of yes drama out of total no comedy. The same thing if I drop it down, I have a share of no drama out of yes comedy and a share of yes drama out of yes comedy. And you see that it's exactly the same. We have a 51% here, 49 here, 51 here, 49 here. So if we focus on the drama, and drama is independent of comedy, it doesn't matter whether comedy is yes or no, there will be a 51% of no drama movies and 49% of yes drama movies. Let's make it a percentage. Go home and click a percent button, and there we have it. Let's do the same thing, but let's focus on the column totals. So we calculate it like this. Again, we delete our raw totals because we don't care about them. And again, so now we're dividing no drama by row. And remember, now if I drag down, I still would like to stay in the row 15, but if I drag sideways, I want to move from J to K. Therefore, I am freezing only the raw. Let's drag it all the way and see what happens. And here I take a sum of my column just to make sure everything is correct, and it's 100%. I highlight everything and click the percent button here, so look at that. Now we're saying we don't care if the movie is drama or not. Among the no drama movies, there will be 68% of movies who are not comedy and 32% which are comedy. Among the yes drama movies, there will be just exactly the same split. So again, a different way to look at it depending on what you're focusing on, whether you're focusing on whether the movie is comedy or not, or drama or not. These are the general split. This is what we're calculating, and this is what these numbers are showing. So all we need to do now is to say, okay, we have our random split, and let's call it like this. And when we say there is no relationship, that means H0. And this is what we're going to test. So all we need to do is produce a p-value. And there is a formula. We're doing a chi-square test, so let's click a chi-square formula, and it asks us what we need to do. So our actual range, here's our actual data, and our expected range. And expected range is baseline, so nothing is going on. There is no relationship. Everything is random, and we click yes, and we get 0. You could have gotten a really random different number, a long one with a minus and everything, so it's a very small number. If you want to get rid of it, right click on it, format, and do 3 values after comma, and then you will get the same thing I will. So this number is definitely less than 5%. It's of course not absolutely 0. There is a 1 somewhere. So when we have a number like this, we say there is significance, and we say p is less than 0.001. So it's very small, definitely significant, but it's not 0. It's never 0. So what does it mean now? We have a significant difference. There is a significant relationship between drama and comedy, but is it more or less often? Are drama and comedy happening more often together or less often together? We can look at our numbers here and say, we have 1,119 here and yes, and 1,600 here. So it looks like in reality drama and comedy co-occur less often than we would expect if it was random. If you want to make it more digestible, you can go back to the percentage, and let's calculate the percentage here. So we already know how to do these manipulations. Value field, show values, and we say calculation, let's do raw total. It doesn't matter, we calculated both, right? So here's our raw total. Here's what we recreated here. Here's our random co-occurrences, and here's our actual co-occurrences. Have a look. It looks like 33, it looks like out of all comedy movies, also 33.5% are drama movies. In our data, we predict if it was nothing, it would be 49. So it looks like it's less than random. Like this is easier to see. So we're comparing 33 to 49. 49 would have been, there is no relationship. 33, there is. So it's actually less likely than random to have comedy and drama together, which makes sense when it's comedy and drama. On the one hand side, there is a rom-com, there is the whole this thing, which is also both dramedy and comedy and romance. On the other hand side, there are also serious drama movies, dramatic movies that will not be comedy, and there are also pure comedy movies that will be connected with something like adventure, not drama. So what it turns out that there is a significant relationship between comedy and drama. They don't just randomly occur, and it looks like drama and comedy are a less popular combination and not a more popular combination. Knowing this, you can make different decisions as to for example, how to market a movie, or maybe which movie would you like to produce if you're a producer, or what kind of a movie would you like to write if you're a script writer or a director, how you would like to film it, and so on and so forth. For example, if you go for less common thing, you might consider going for comedy drama combination. Or if you think, okay, this is not a popular combination, it's significantly less popular than we would, less common than we would expect randomly. Whether it's a good thing or a bad thing is at your courtesy, it's your decision. If you want to go wild, then maybe make this combination. If on the contrary you want to stay in line in the mainstream scenario, then maybe this combination is not recommended. So this is how you do a chi-square test. This is how you test the relationship between two categorical variables. Remember, we have drama yes, no, and we have comedy yes, no, and we check whether their co-occurrence in life or in our data is random or there is some dependency. And we found out that P is less than 5%. It's significant co-occurrence of comedy and drama, or better said, the lack of thereof, is not random.